Is it
Yes,
clear
ma'am.
now?
Yes, ma'am.
Okay,
Yes, ma'am.
okay, okay. So within the limited bandwidth constraint, we need to transfer the data efficiently. Okay, we need to transfer the data efficiently. Okay, that is the main design constraint what we are having. Okay, now first is there are so many points. Okay, first one, heterogeneity, distributed processing, low bandwidth communication. Within the limited bandwidth, we need to communicate or we need to transfer the data efficiently between the sensors. And we need large scale coordination mechanism with each sensor nodes, right? So to produce the that is accurate result. Okay, then we need to utilize all the sensors because we are just spreading, we are just deploying the sensor as such, we are just throwing the sensors, right? So we need to utilize all the sensors effectively. So then the real-time computation, that is if the temperature changes or if the some natural calamities, like whatever may be, we need to get the data immediately and we need to compute the information quickly, and the data always the new data will be generated. So this real-time computation is also a design challenges. So these are the design challenges. And next is technical challenges. Technical challenges, design challenges, there are so many challenges in the wireless sensor network. Actually this the populating the world with the networks of sensors, it requires a fundamental understanding of these techniques for connecting and managing the sensor nodes with the communication nodes. Okay, and always the network should be scalable. Scalable in the sense, uh, at any time, any node can move from the network, or any node can enter the network. That property we'll be saying it as scalability. So at any point of time, the nodes can be moved away from the network, or some nodes may join the network. Okay, so our network uh, should give space for all the nodes those who want to join in that network also. Okay, that property of the network is called, that property of the network is called scalable property. So the network should be scalable and the network should be resource efficient. Always it should provide resources to all the nodes. Then only the nodes can able to withstand, or nodes can able to survive in any condition, and it can be able to get the information, and the information can be processed and it will be reached the user. So clearly a sensor network belongs to the class of adapt network. The first class itself we have seen, right? So the sensor network belongs to the class of adapt networks, but they have some specific characteristics that are not present in the general adapt network. So adapt network and the sensor network, it shares a number of challenges, so, like energy constraints and routing. Okay, so this adapt network most likely include traffic pattern, and the traffic pattern for adapt network is different from the sensor network, and the lifetime requirements also will be different. And this adapt networks are most often considered to be a mobile node. Okay, so mobile node in the sense movable node. Okay, so in wireless sensor network, most of the nodes are static. Okay, here we are studying the difference as well as the design challenges. Okay, so already I told you sensor wireless sensor network is one form of adapt network, but the energy constraints and routing will be mostly same as that of the sensor network, wireless sensor network. Okay, adapt network and sensor network share the challenges like energy constraints and routing. But this another adapt network, it mostly it induce the traffic pattern which is different from the sensor network. Okay, and This ADAC networks are mostly mobile network, but wireless sensor networks are mostly static network because we are just throwing the sensors, and if the sensor is deployed in one place, it will be there only. Okay, so wireless sensor networks are the nodes are static. However, the network the network of basic sensor nodes may be overlaid for more powerful mobile sensors, okay, like robots, and it is guided by the basic sensors, and it can move to the interesting areas or even track the intruders in the case of military applications. Okay, this sensor nodes will track the intruders in the sense attackers. It will track the attackers in the case of military applications. So the network nodes that are equipped with wireless transmitters and receivers using antenna. So this antenna may be omnidirectional, or we can say, you have studied antenna, right? It can be omnidirectional. Omnidirectional in the sense it is isotropic radiation. Okay, so the network nodes are equipped with wireless transmitters and receivers using antennas, and these antennas may be omnidirectional, that is isotropic antennas. That is, it is highly directional. That means it is point to point. Okay, and it is possibly steerable and some combinations. Okay, with some combinations. So at a given point in time, depending on the node's position and the transmitters and receivers coverage pattern, this transmission power levels and co-channel interference levels and wireless connectivity exist in the form of random multi-hop graph between these nodes. Okay, so I'll repeat this network nodes. I'm telling you the general thing, then I'll come to the design. Okay, so the network nodes are equipped with wireless transmitters and receivers. So transmitter and receiver is nothing but some antenna, right? So here the antenna what we are using is omnidirectional antenna, that is, it is highly directional. So we can say it as a point to point antenna. Okay, so at any given point in time, depends upon the node's position and the transmitter and the receiver's coverage pattern, this transmission power level and the co-channel interference level and wireless connectivity exist in a form of random multi-hop path between these nodes. Okay, so multi-hop in the sense from one node, it is not connected. 1 minute. Please wait. I'll draw it and I'll show you what is multi-hop. So consider there are some nodes like this. Okay, so if an information is going from this node to this node, this is single hop. Okay, so suppose some information needs to come to this particular node, then it will be taking the shortest path, and it will take several multiple hops. So here it takes 1, 2, 3, 4, 5, 6. Uh, uh, that is uh, from one node to another node, it will be considering it as single hop, one hop, and this will be considering as two hops, and this is three hops. Okay, that is jumping from one node to another. The information will jump from one node to another, from this node to here, then this node to this node, this node to this node. So if it crosses multiple nodes, then we'll be saying it as multi hop. Okay, from here to here, in the sense, we'll be saying it as a single hop. This is two hop. Okay, and if it is more than two hop, we'll be calling it as multi hop network. So that is multi hop. So based on the receiver's position and transmitter's position, and also the node's position, this transmission power level and the co-channel co-channel interference in the sense, assume that There are so many nodes. Okay, this node, and we can reuse the frequency, right, in the mobile communication same way. Assume that this node and some other node is using the same frequency. Okay, using the same frequency. Suppose if the interference from this channel is reaching this channel, then it will be we'll be calling it as co-channel interference. And suppose if the we are get this is adjacent channel, right? So if this node receives some interference from this node, then that will be called as adjacent channel interference. Okay, there are two types of interference we can receive. One is adjacent channel interference, and the other one is co-channel interference. The co-channel interference is if two nodes are using the same frequency, then if we are receiving some interference from those two channels, that type of interference will be called as co-channel interference. And if though these two nodes are using different frequencies, some interference this node is receiving from this node, then this type of interference is called adjacent channel interference. Are you able to understand these two types of interference? What is adjacent channel interference and what is co-channel interference? Yes, Jovin? Jovin? Jovin Kinsley? Are you here? No. So Jovin is absent now. Register number 90.
Ma'am, can you repeat it again, ma'am?
Yeah. See here, there are, this is one network, okay? Assume that this is one network. So in the network, there will be number of nodes, okay? This circle, small circle indicates number of nodes, okay? Assume that this node A and this node, consider this as X, okay? So this node A and node X are using same frequency. Okay, and if we are receiving any interference from this node to this node, okay, then this type of interference is called co-channel interference. Okay, co-channel interference. Okay, now these two nodes are adjacent to each other, right? So if these two nodes are receiving interference from other node, then this type of interference is called adjacent channel interference. Is it clear? Is
Yes,
it
ma'am.
clear?
Yes, ma'am.
Yes. Okay. So suppose if you don't understand any point, immediately you can ask me to explain once again. Okay. Don't ask me. Don't think that I will ask you in all times. Okay. Please, if you are not able to follow even a single step, you can stop me at any time and you can ask. Okay. So so this uh, this this is one challenge, right? So this attack topology may change with time as the node move or adjust their transmission and reception parameters. That is, this is based on ad hoc network, because ad hoc network it is movable. Okay, and because of most challenging issue in sensor network, the most challenging issue in the sensor network is the limited and unchargeable energy provision. Okay, since just we are just throwing the sensor as such. Okay, and here the uh, power or the energy is limited, and we cannot recharge it using some battery or not, and all. We are not able to recharge it just because we are just throwing the sensor, and we ourselves will not know where the sensor is placed, right? The sensor is minute particle, that is like dust. Okay, this is like a dust dust particle. So we will not be able to go and search each sensor and charge. Okay, so this is limited energy provision. Okay, that is, it is not, we will not be able to recharge it. Okay, so that is the most challenging issue in the sensor network, that is limited and unchargeable energy provision. So the uh, many of the researchers are doing research to improve this energy efficiency from different aspects. Okay, so in sensor networks, the energy is consumed mainly for three purposes. Okay, so the sensor network energy is consumed for only three purposes. One is data transmission time, and as well, then during the signal processing time, then the hardware operation time. Only these three areas we need, that is, the energy is consumed only for these three purposes only: for data transmission, signal processing, and for hardware operation. The energy is consumed. So it is desirable to develop energy efficient processing techniques, okay, that may minimize the power requirement across all levels of this protocol stack. So at the same time, minimizing the message passing for the network control and coordination. So here, mainly, if you consider any research in wireless sensor network, so the performance metric, performance metric may be for performance metric, in the sense what are the parameters we can analyze. Okay, so the performance metric may be energy efficiency, or we can say it as a system lifetime. Okay, energy efficiency. So once energy is lost, the lifetime is over, right? So uh, once energy is drained, that's all, we cannot recharge it. So energy efficient and system lifetime. Then latency is nothing but the delay. Then accuracy, fault tolerance, scalability. Then the transport capacity, that is the data transfer capacity, that is nothing but the efficiency. But in the networks, we will not call this as efficiency, we'll be calling it as throughput. So these are the basic parameters, they'll be, all the researchers will be analyzing in all the networks. Okay, so the performance metric will be energy efficiency, or we can say it as a system lifetime. That is nothing but the sensors are battery operated, right? The sensors are battery operated, and rendering energy a very energy, it considers the energy as a very scarce resource. Okay, and this energy must be wisely managed in order to extend the lifetime of the network. Okay, so this is about energy efficiency parameters. So the sensors are battery operated, and the sensors will consider the energy as a scarce resource. Okay, and this must be wisely managed in order to increase the lifetime, okay, of the network. Next is latency. Already I told you, latency is nothing but the delay. So many sensor application require delay guaranteed service. Okay, so that is, the protocol must ensure that the sensor data will be delivered to the user within the certain time. Okay, without, that is, within, with limited delay. Suppose today's weather report, if you are getting tomorrow, then there is no use. Okay, suppose if there is any, what to say, earthquake or something, so we need to give the information well in ahead, so that the people there in that particular place can be saved. If suppose if there is any heavy rain or any cyclone, the information has to reach that particular area well in advance. Okay, after cyclone, if it reaches, then there is no use. Okay, so within certain delay, the information has to reach. Okay, so uh, that that is, many sensor application requires delay guaranteed services, right? So the protocol must ensure that the sensed data will reach the user with certain delay. Okay, so within a certain delay. If the delay is more, then there is no use in that particular network. And also, again, accuracy, we need to get the third parameter is accuracy. So we need to get the accurate information. Okay, so the primary objective of the wireless sensor network is obtaining the accurate information Okay, obtaining the accurate information. So this accuracy can be improved through like joint detection as well as estimation. So when we are detecting the information and how it is estimated properly, so the estimation should be very accurate. So rate distortion theory is possible tool to access the accuracy. So we are not going to study. So to access the accuracy, the tool is rate distortion theory. Okay, so based on that we can analyze the accuracy. Then also fault tolerance. Fault tolerance is nothing but the robustness of the network. Robustness is nothing but the stability or strongness of the network. So uh, so how it acts when a link failure, like, okay, so fault tolerance, the robustness to sensor and link failure must be achieved through redundancy and collaborative processing and communication. That is, suppose if there is a link fails, there should not be any communication, that the communication should not be stopped. Okay, somehow the communication should reach the user. So accordingly it has to find out some other path, some other alternative solution, like some redundancy should be there. Okay, the so that the information can be reached the user without any delay as well as without uh, any distortion or without any loss of data. Okay, next is scalability. Scalability, in the starting of the class itself I told you, that is, um, the network should give space for the other nodes to join as well as the nodes to leave also. So because sensor network, it contains thousands of nodes, the scalability is a critical factor here, and it guarantees the network performance. And also, uh, so if we are adding more nodes, if we are giving a space for entering more nodes, then the performance of the network should not be should not degrade. So we need to make a network in such a way that we can adopt other nodes also, but because of that adoption of other nodes, the performance should not be degraded. Okay, so and that is perform, that is, if you are adding more nodes, naturally the size of the network will increase, right? So if the since the size, that is, because of increasing in size, there should not be any performance degradation. Okay, so that thing we should make sure. Then the throughput. So most of the sensor data must be delivered to a single base station. Okay, single base station, that is a critical area in the sensor network exists. That is, the sensor node must relay the data generated by virtually all nodes in the network. So the traffic load at those critical nodes will be heavy, even when the average traffic rate is low, because all the information will come to the sync node. Then through the sync node only, through internet, the user will get the information. So if the average information is low in the network also, this sync load will be the information of the sync load will be heavy. So because of that, the performance should not degrade. So we should design a network in such a way that whatever may be the situation, you should get the maximum efficiency. So in the network term, we will not say it as efficiency, we will be telling it as a throughput, or we can say it as transport capacity. So throughput is the number of data transmitted without any error. It is divided by uh, the total data transmitted, right? So I'll repeat it. It is the ratio of number of packets transmitted to the number of packet transmitted without any error, number of packets transmitted without any error to the total number of packets transmitted. For example, if we are transmitting totally 100 packets, okay, out of which 75 packets have reached the destination receiver without any error, and 25 packets have lost or reached with the error. That means the efficiency, or we can say that the throughput is 75 percentage. 75 by 100. 75 packets without any error. Okay. Total packets transmitted is 100. Okay, likewise we can define the throughput. So when you say that technical issues, okay, technical challenges for wireless sensor network, the first point we need to write all these parameters. Okay, so that is nothing but the performance metrics, and the second point is nothing but the power supply. So second point is power. So these are the challenges. So here the second point we should say about the power supply. So the most difficult constraint in the design of wireless sensor networks are those regarding the minimum energy consumption necessary to drive the circuits and possible micro electromechanical devices, that is MEMS devices. Okay, MEMS is nothing but micro electromechanical devices. So the energy problem is the most difficult and most challenging problems. So if actuators are present, then substantially this energy can be drained. So mainly we need to conserve the energy. So this energy efficiency, and also each node will have a limited storage capacity. Okay, that is the memory capacity is less, so each node will have a limited storage capacity. So this computational capacity, that is that we need to compute in all the informations and we need to store it in the node, then in the sensor node, then the stored information has to reach the sync node. Sync node has to store all the information that is receiving from all the nodes, then it has to come to internet. From the internet it has to come to the user. So here the another challenges is limited storage and compute computation. Then I already told you the bandwidth constraint is very less. The bandwidth is less. So within the less bandwidth, we need to transfer more amount of data. Okay. So because of that, uh, high error rates will occur. So we need to get a data. We need to get the data with the minimum error. Okay, that is in fact there should not be any error within the limited bandwidth. The user has to get the accurate information. That is a major challenge here. Then usually errors are common in wireless communication because the noisy measurement, and sometimes the nodes may fail. Okay, that is the sometimes the low nodes may fail, sometimes the link may fail, sometimes an intruder may come and sit in that particular network. There are so many challenges are there in the era. Okay, so we need to be more cautious for all those things. Then I told you about the scalability, and I told survivability, that is if the energy is drained then it is very difficult to survive. So we should maintain the energy level also. Okay, so these are the major operational challenges of the wireless sensor network. Next is enabling technologies. So the embedded, mainly it will be in the embedded network. So it will be so wireless sensor network uses the enabling technology. Okay, so it may be embedded numerous distributed devices to monitor and interact with the physical world. Okay, and the network devices, the function of network, actually the sensor network will be embedded and it is a network form and there will be a sensor, right? So in the wireless sensor network, this these sensors are embedded numerous distributed devices to monitor and interact with physical world, and also this network devices has to coordinate among themselves to perform the major task, and also it exploits spatially and temporarily dense. Okay, so for sensing and for sensing, as well as it has to give the accurate devices. So together, this embedding, networking, and sensing forms the wireless sensor network. So this already I told you the challenges. Energy is the challenge, communication range, bandwidth is the challenge, computation, storage, then charging, battery depletion, node failure. Okay, so node mobility may be in ADAC network because sensor network it is mostly static. Okay, then that sometimes the link may become unreliable due to noise or jamming. Okay, so the dynamically changing the bandwidth range and computation power interaction. So the in general these are all the major challenges. Okay, so and the factors influencing the design. While designing a wireless sensor node or wireless sensor network, these are the factors we need to consider. That is fault tolerance, scalability. That is fault tolerance. We have studied what is fault tolerance. That is one performance metric. Scalability also we have seen. Then we need to concentrate about the production cost, then in which condition this particular sensor network is working, that is operating environment, and which type of topology we need to use, and what are the hardware constraints, and what about the transmission media, then power consumption, data management, then that it is deployed in some geographical area, right? So in that area, what are the geographic routing challenges, and how to monitor and how to maintain that networks? Everything we need to consider while designing a wireless sensor network. Okay, these are the main points we need to consider. So these are the desirable features which leads to sustainability. That is low power consumption. Okay, then joint optimization of connectivity and energy efficiency, then self calibration and self healing. So I told you self calibration and self healing is it will be on anytime, anywhere, right? On the fly network. We will be seeing it as a on the fly network. At any time it can be formed and at any time it can be deformed. And also if any link or node fails, it has to heal automatically. Okay, that is the without any distortion in the communication, it has to connect automatically. So that is nothing but self healing, recovering from failures and errors in which wireless sensor networks are found. And efficient data aggregation, efficient data aggregation, then short development time, programmable and reconfigurable stations, system security, and simple installation and maintenance procedures. So these are the desirable wireless sensor network features leading to sustainability. If you concentrate all these parameters, then we'll be able to design a wireless sensor network which will sustain for long time. Okay, so we'll stop with this. If you have any doubt, you ask me, and in the meantime, I'll take the attendance. Ajay,
Yes, ma'am.
Ajay,
Yes.
Abhishek, Abhishek,
Present, ma'am.
Jeevan,
Present, ma'am.
Andrew Michael,
Present, ma'am.
Sherwin, Sherwin,
Present, ma'am.
69,
Present, ma'am.
Amarnath, Govardhan. So if you are putting it in chat box, please inform me. Others,
Golden
please
here, ma'am.
inform.
Ma'am,
Govardhan. Okay. Okay.
Amana
Okay.
is putting in chat box, ma'am.
Okay, ma. Okay. Govardhan,
Yes, ma'am.
Nikita,
Present, ma'am.
Hariharan,
Present, ma'am.
Hariharan,
Present, ma'am.
84. Okay, ma'am. Okay, Jovin. Jovin. So in the class also I called his name. He has not responded. Jovin. Sam.
Present, ma'am.
Julian.
Yes, ma'am.
Patrick.
Present, ma'am.
Kevin. Kevin. Sanjay.
Present, ma'am.
Prince. Prince. Harika.
Present, ma'am.
Pallavi.
Present, ma'am.
So absentees are register number 104, 90 and 109. Jovin Kingsley, Kevin and Prince. Do you have any doubts, ma?
Yes, ma'am.
Yes, Jeevan, tell me.
Ma'am, are these features? Do they exist, or they are hoping to be existed?
They are existing.
Oh,
Existing.
okay, ma'am.
Oh, okay. Existing. Any doubts? Okay, ma. If you don't have any doubts, you can leave. Thank you, ma. Thanks for attending. Thank you.
Thank you, ma'am.
Thanks.